Do you know what happens when a star dies? It depends on the size of the star. It's large enough, it will explode into a supernova and leave behind a neutron star, a black hole. You might think that this would be the end of it, but these objects have some sinister secrets that will blow your mind. In this video, we're going to take a look at what happens when a star dies and explore the shocking truth about neutron stars and black holes. Get ready for an out-of-this-world adventure that will leave you in awe of the power of the universe. So buckle up and get ready to blast off. When stars die, when a star dies, it can leave behind a neutron star or black hole. A neutron star is a highly dense object that is formed when a star collapses at the end of its life. These stars are typically around 10 to 20 times the mass of our Sun, but they are only about 10 to 20 kilometers in diameter. To put that into perspective, if our Sun were to become a neutron star, it would be just over 20 kilometers across, which is about the same as the distance between London and Brighton in the UK. Neutron stars are so dense that a teaspoon of their material would weigh more than a mountain. They also rotate very quickly and have strong magnetic fields, which can cause them to be incredibly luminous. However, these objects are still relatively small compared to black holes. A black hole is a region of space-time where gravity is so strong that nothing, not even light, can escape its grasp. They are formed when a star that is many times larger than our Sun collapses in on itself. The most common type of black hole is the stellar black hole, which can range from a few to several dozen times the mass of our Sun. However, scientists believe that there are also supermassive black holes that can be millions or even billions of times the mass of our Sun. These giants are found at the center of most galaxies, including our own Milky Way. Black holes are truly terrifying as they have a singularity at their center, which is a point of infinite density and zero volume where the laws of physics as we know them break down. Anything that gets too close to a black hole will eventually cross the event horizon, which is the point of no return. Once inside the event horizon, it is impossible to escape the black hole's gravitational pull, and anything that enters it will be pulled apart by the immense forces and will never be seen again. So now that you know what happens when a star dies and have a basic understanding of neutron stars and black holes, it's time to explore some of the shocking secrets these objects hold. Secret 1: Superflares. One of the most surprising things about neutron stars is their ability to produce superflares. These are massive bursts of energy that are much more powerful than any flare that occurs on our Sun. In fact, the largest flare ever recorded on our Sun is only about 1% as powerful as the smallest known neutron star flare. The reason why neutron stars can produce such powerful flares is because they have such strong magnetic fields. These fields can cause charged particles to accelerate to nearly the speed of light, which creates powerful bursts of radiation. Superflares from neutron stars can release as much energy as 100 billion nuclear bombs, which is truly mind-boggling. This makes them one of the most violent phenomena in the universe, and a reminder of the incredible power that these objects can possess. Secret 2: Gravitational waves. Another fascinating aspect of neutron stars is their ability to produce gravitational waves. These are ripples in space-time that travel at the speed of light, and were first predicted by Einstein's theory of general relativity. Gravitational waves are produced when massive objects accelerate, such as when a neutron star or black hole is formed during a supernova explosion. As the star collapses, the immense amount of matter is suddenly compressed into a much smaller space, which creates a massive amount of gravitational energy. This energy is released in the form of gravitational waves that radiate outward from the collapsing star. Gravitational waves have been detected indirectly through the study of neutron star mergers, and have provided an exciting new way to study the universe. By analyzing these waves, scientists can learn more about the properties of neutron stars and other extreme environments in space. Secret 3: Time dilation. One of the most bizarre aspects of black holes is their ability to cause time dilation. This means that time passes slower near a black hole than it does far away from it. This phenomenon is a result of the curvature of space-time caused by the intense gravity of the black hole. The closer you get to a black hole, the stronger the gravitational pull and the slower time passes. For example, if you were to approach a black hole, you would notice that time on Earth would seem to pass much faster than it did for you. This means that if you were to spend even a short amount of time near a black hole, you could return to Earth and find that years or even decades had passed. This is a direct consequence of Einstein's theory of general relativity, and has been confirmed by experiments with atomic clocks. Secret 4. Spaghettification. Another terrifying aspect of black holes is their ability to stretch and distort objects that come too close to them. This process is known as spaghettification and occurs due to the extreme gravity gradients near the event horizon. If you were to fall into a black hole, you would experience a massive amount of gravitational force pulling you towards the singularity at its center. At the same time, the part of your body that was closer to the black hole would be stretched out, while the part that was farther away would be pulled in. This would cause your body to be stretched into a long, thin shape, similar to spaghetti. And due to the intense gravity, you wouldn't even be able to move your limbs or make any sounds. This would be a completely silent and horrifying experience. Secret 5. Firewall paradox. One of the biggest mysteries surrounding black holes is the firewall paradox. This is a theoretical problem that arises from the conflicting predictions of quantum mechanics and general relativity. According to general relativity, as you approach the event horizon of a black hole, the gravitational pull becomes infinite, which means that anything that crosses the horizon must be destroyed by the intense gravity. However, quantum mechanics predicts that as you approach the horizon, the particles in your body should be reflected back out towards infinity. This is known as the particle horizon. The firewall paradox arises because these two predictions seem to be contradictory. How can an object be both destroyed by the infinite gravity near the horizon and reflected back out towards infinity? One possible solution to this paradox is that there exists a firewall near the event horizon, which is a region of space where all incoming radiation is reflected back out, preventing anything from crossing the horizon. However, this solution raises its own set of problems. For example, it would require new physics beyond our current understanding to explain how such a firewall could exist. The firewall paradox remains one of the biggest open questions in theoretical physics today, and finding a solution to it could revolutionize our understanding of the universe. These are just a few of the many secrets that neutron stars and black holes hold. These objects are truly fascinating and terrifying, and remind us of the incredible power of the universe. What do you think of these sinister secrets? Let me know in the comments below. And if you enjoyed this video, don't forget to like and subscribe for more amazing content. Thanks for watching. Until next time, keep exploring the wonders of the universe.